Well, hello everyone. I hope you can all hear me, and good afternoon to you and good evening on my side. I'm glad to be joining you I'm glad to join you here for this event, MI conference, and I thank the MI conference organizers for inviting me for a talk. And my talk is going to focus on natural language processing for low resource languages. And before I continue, I would like to introduce myself. Actually, my name is Gloriana Monko, and I work at the University of Dodoma, and I come from the Department of Computer Science and Engineering. I'm also liaison manager for Artificial Intelligence for Development Anglophone African Lab, which is also hosted at the University of Dodoma. I'm also a co-founder of Telesoft AI and Women Supporting Science. I'm currently a PhD student at Shibaura Institute of Technology here in Tokyo. So we are in different locations, but we can still get to hear or to see one another on this huge event. And I'm glad to join you here. So the reason why I chose this topic, I think there is a motivation behind, and I would really like us to think about this together before I proceed with my talk and later to discuss more about it. And this is something that I've been asking myself, and probably you have been asking yourself on your end. What will the future communication look like? Since we do have the digital revolution and, there have been a lot of transformation going on, and we do understand how the communication is central part in how we live. But yet there is so much to be done using the advancement of technologies. So taking an example or taking an opportunity of the technology in hand, the artificial intelligence technology, what do we have, or what does the technology has in store for us for the future communication? That is something that I've been asking myself, and I think everyone else has to ask this to ask themselves this question. And before I continue with my presentation or my talk, I would like you to take just 2 minutes to go through 3 questions that I prepared, and I wanted to understand whether we are in the same position. I mean, we are in the same boat. We understand each other, so that we can have a better understanding of the concept itself. So I would like you to take only 2 minutes. If you have a tablet or a smartphone or a laptop, you can just go to menti.com and enter the code, so that you can just reply to the questions that you'll see on your screen. And this will help me to continue with my talk, just to know that we are on the same page. I would really appreciate if we all reply on all of the questions so that we have a general understanding. Just 1 minute more and we continue. Well, Stephanie, allow me to continue with my presentation. Thank you so much, guys, for responding on these questions. They are really important for me to understand who I'm talking to and how I can deliver my talk in regard to the type of participants that I have. Zephania, are you there? Well, I presume everyone has answered almost all of the questions. And if you have not yet done, you can continue responding to it. So I will continue with my presentation. Well, so from the replies that I got from you, from the participants, I could see that a huge number of people, probably this is their first time hearing the term natural language processing. And so I need to explain more about it before I jump into the main topic or the main talk. And looking at the number of people who have interacted with applications which have been built on NLP, I can also see a huge number of people. They say they have interacted with some, and 32%, 58 say yes, and 32% said no, and 11% maybe. So it's not a bad thing, and that means at least people do understand and they know these applications. But again, with the examples of the applications, I've gotten a lot of examples. Some of them I wasn't even aware of them, and thank you for adding that on my list. And I can see Google Translator, Google and Twitter and conversational AI and digital translation are the ones leading on some of the applications which many of you know or have interacted with. So thank you for that feedback. And I will just kick on my topic, which is about natural language processing on low resource languages. And to start with, I want us to understand the idea, the entire definition, or the definition of natural language processing. So looking at this diagram, I think it can simplify the definition of natural language processing, because you're taking two fields and combine together, and you get, and the NLP becomes an intersection of the two fields. We have computer science, which is a field deals with computational, automation of our systems and the rest. But again, we do have another scientific field which deals with languages, which is linguistic. And having these two fields together is what makes natural language processing. And natural language processing actually is one of the major branches of artificial intelligence, and it is being implemented whether using machine learning approaches or techniques, but again, or deep learning techniques. So that could be a very simplest definition by looking at this diagram. And if we have to define it in terms of how the computer interacts or how computer learns from NLP, is a technique that is used by computers to understand natural human language. So just like how humans communicate with one another is how a computer is being trained to understand the same way as normal human beings interact. So we can say that natural language processing is just a term which has existed for several decades, and it has become everyday part of our lives, whether by knowing or by not knowing. We have been interacting with a lot of applications being built by NLP. So just like any other people who have mentioned some of the applications. So the presence of NLP has brought a lot of advantages in our daily lives. And we do interact with these applications each and every day, and we do understand the advantages of these applications in our daily lives. So taking an example of Google, which is one of the biggest search engines that we have, how does it work? So Google, it works, NLP is used in Google, for instance, in information storage and retrieval, how we store the information and how the retrieval of information, how you actually query your information, or you query something and you get a feedback, or you get a reply on whatever that you ask. And this is one of the applications that I think it doesn't pass a day a person has not interacted with. Personally, I use it just like I eat my food, or probably more than what I do eat every day. So it is one of the most important applications. And if it goes down, I think people sometimes they get sick because they rely so much on Google. And Google has a lot of applications in it. We do have Google translators, which have been used for machine translation, question and answering, for the frequent asked questions and whatsoever. We have applications like Siri, which is used by iPhone or Apple products in dialogue systems. We do have some robot chats, like in Amazon, when a customer requests for something and they get a quick feedback from those robot chats. So it is easy to interact with these e-commerce systems when you know that there are some applications working behind the bags. So we do have Netflix, which is also one of the biggest platform for viewing movies. People get to rate movies, whether they are good or not good. So that is all about sentiment analysis and whatsoever. So we do have a lot of applications when it comes to natural language processing. And taking an example of how they can fasten and make businesses perform better, for instance, with chatbots, they deliver fast and they also support customers in a very fastest way. Just taking an example of hiring, maybe how many people you would hire to serve for billions customers who are interacting with Amazon platform. You can just take an example of just requesting for more clarity on a particular product, or maybe you want to return a product. You want to give some you want to give some reasons for why you had to return a certain product. So that would have been so difficult interacting with an individual one-to-one. But with chatbots, it's easy because they use some templates and they use ready-made chats, which can actually be efficient in replying customers. So this has made a lot of processes or a lot of businesses to perform in the best performance because of having that quick and proactive customer service. And coming to the fact that natural language has got a lot of applications in our daily lives, but again, teaching a computer or training a computer to understand human language is not as easy as it sounds. It is so difficult because a computer has to comprehend whatever that a human has to understand about semantics, syntax, morphology, phonology of the sentences and all that. So it is not something that it is so easy to interact with. I mean, like it is so easy to train a model to understand all this. And there are so many issues in regard to that, because when you come to train a machine to understand a particular term, you can find some of the terms they are very ambiguous. For instance, using the word bank or maybe chair. this can be used in different way or in different environments. For instance, if you use bank in finance, it is understandable that bank is just a place where you can store your money and you retrieve or you can just perform finances activities. But looking at the bank on another way, on the other hand, when you define according to, rivers, there is river banks. So how does a computer understand the two different terms? They can stand in two different environment, or a chair if it is used as a noun or a verb. So you can see this ambiguous and linguistic diversity can actually bring a lot of challenges when it comes to training models using natural language processing. But again, coming to the point of low resource languages. This is our main discussion today, because with low resource languages is even more harder to train machine to understand, given a very minimal number of data. So I will just jump into the main idea after I've introduced what NLP is all about and the application of it. But the main discussion is about the natural language, the low resource languages. How can they benefit from the NLP application in building their models for solving some of the challenges using the low resource languages? So whenever we train models or whenever we deal with NLP, we often refer these languages as low resource languages or high resource languages. And why are they being categorized in those two domains is because when you have a lot of data, resources in a particular language, that is considered to be a high resource language. For instance, English or French or maybe German, those are considered to be high resource languages because they are very famous and they have been used a lot, and there are enormous amount of data in those languages compared to low resource languages, for instance, Swahili or other languages like Hindi or any other languages which are considered to be low resource languages. And why do we care so much about this is because, first of all, we do have a lot of languages in the world, and they could count up to 7,000 languages in the entire world, but only a very small fraction is considered to be high resource languages, which is about 20 languages are considered to be in high resource languages. So you can imagine the rest of the languages are being considered as low resource languages. And yet we need to develop a lot of applications which can help, they can help our societies with different problems which are related with NLP problems. So how do we make sure that we are also able to solve problems with limited resources that we have? That is the main discussion here. And looking at this is a research which was done by Neurospace, and looking at it, you can see the differences. These statistics here, it shows the NLP solution which were developed in high resource languages and in low resource languages. You can only see 6% of it comes from low resource languages. These are the NLP solutions which were developed in low resource languages. But again, looking at the English, using English language, we have a lot of applications in that domain. But looking at some of the European countries, it's quite a good number as well. But looking at the population size, vis-a-vis the language, the population size of the languages which are being spoken, you can see a huge number of it is the 68% is low resource languages. And this actually covers most of the Asian countries and the African countries. only very few number of languages in Asian countries like Japan and Chinese have been well covered, unlike the rest of the languages in Asian countries. Likewise, in Africa, most of the languages are being considered to be low resource languages. So we do have these few number of solutions because these languages are not well covered, they are not digitized, so we do not get access to information, or access to data when we train these models. So it becomes difficult to come up with a lot of NLP products or NLP softwares. So as I said, it is estimated actually by 2016, the product or the software with NLP features to generate about 48 billion USD. And this is quite a huge amount of money. But are we in a position of taking this chance to be among this, or to deliver a lot of softwares using the languages that we have in our countries or in low resource countries? And one of the major challenges that we face in most of the developing countries is lack of annotated data set. And this is something that it is undeniable fact, not only in NLP related problems, but even in any other machine learning related projects, because we get to look at the quality, the quantity of the data, and all those issues. There have been a drawback in many of the ML project related. So coming to natural language processing is even harder because most of the data are unannotated, they are unlabeled, but not only that, even the accessibility of getting those data is not as easy as it is being discussed here. So we do have these challenges in hand, and yet we are supposed to deliver, or we are supposed to take an advantage of the technology in hand so that we can deliver better solutions. And yet we need to see how can we get, or how can we leverage the existing tools and resources to overcome these resource barriers, such as lack of data and lack of annotated data, so that we can advance in delivering the solutions in which are using NLP technique. So one of the opportunities that we do have some of the languages which are, or most of the languages, they have these similar they are very similar in linguistic, and they are related, so they may share some kind of same lexical and syntax structures and whatsoever. So having this opportunity can actually help us to come up, or to use the high resource languages, the pre-trained models which have been trained on high resource languages, and be able to train on low resource languages. So this is something that is an opportunity and we can use, but we need to see which one fits best according to the data that you're supposed to access, or according to the data that you're working on. So there are several approaches in leveraging the high resource languages in order to improve the low resource translation. For instance, we can use the parallel data approach. And this is an approach where you can actually mix up the limited parallel data pair in low resource languages along with the high resource languages. It's like you are using both languages, in training models, so that you can actually combine these the languages in providing a better, or in coming up with a better performing model. But again, there is this multilingual learning where you can also train a single model in multiple languages. And the essence of doing this is to be able to compare and I mean, since you can have similar syntax in these different languages, so you can learn from one model how it works and be able to implement on the other language, I mean, on the low resource languages. So you can use this multilingual learning approach, which is one of the best strategies as well, by training several models, by training several languages in a single model, and see how they perform, how they can have those similarities, so that you can actually borrow from one another. So, and another one is data augmentation. I think this is the most cheapest and the simplest way, because it is easy to, to alter some data to come up with enough data set out of the little data set that you have. And how is it achieved is because you can actually, you don't even need to go and collect data set from maybe from the field, or you collect new data sets which are not even existing, but you can actually augment the data set that you have by flexing of, if you have maybe a term saying that I'm studying artificial intelligence, you can start, altering that sentence into different formats. Maybe I'm going to study artificial intelligence. Artificial intelligence is one of the technology which is being studied a lot. So you can alter those kind of sentences in different way, so that you can have a more richer data set, instead of going back and collecting new data sets. So that is data augmentation. But the most important thing here is about the introduction of transformers. So we need to take advantage of transfer learning strategy as well, or transfer learning technique, which has been used by most of the applications. Even Google, they do that a lot. Facebook, they came up with pre-trained models, even BERT, which is used in Hugging Face. So these pre-trained models, they have been trained in high or resource-rich languages, and you can actually use those pre-trained models to train your model, which has low resource or the limited number of data, and come up with a better performing model. So by doing that, I think we can come up with better solutions. For instance, I can take an example of myself. I'm doing a research on discovering the drug adverse reactions on patients, and I'm using NLP to deploy my model, because I'm dealing with text, and the data that I'm using, I'm dealing with text. And the good part of it, the worst part is that we do not have enough data. So I've explored and I've seen a lot of challenges that we have. We do not have enough data, and there are no quality data that I can use to train my model using my local data set. What I had to do, I had to figure out on how I can deliver the best performing model by using or by taking advantage of the pre-trained models. So what I had to do, I had to get some pre-trained models, which was BERT, and it has been trained in English language. And the good thing is that my data were also in English language. So at least it was a good chance that I have to train my model, which has been, I have to use the model which has been trained in English, but also use the data set, the little data set that I have, to train my model on top of the pre-trained models. So that itself, it helped to improve the performance of the model. And this is what I think is the best chance that we could take when we need to train the low resource languages, and to come up with better solutions which can be helpful to our countries. Since the communication is central of how we live and how we communicate, I think we need to do that, and we need to act quickly on how we can collect enough data set for our languages. For instance, we are doing really well now with the Swahili dataset, and we can see the improvement even in translation in some of the applications that we interact. For instance, the application like Instagram, which one of the most popular application, we can see the translation is much way better compared to previous years because we didn't have enough data set in Swahili for machine translation. But for now, people are really contributing on Swahili data set. For instance, in one of their platform, which is being hosted in Mozilla. You can also contribute some of the Swahili data set there so that we can use those data sets to be able to come up with different models in which are language related models. And just to wind up my discussion, so this is something that we need to tackle, and we need to see how the future, the future of communication will look like. We will no longer have to learn a foreign language to communicate with others. For instance, I'm here, these people, they don't speak English, they only speak their language, and I'm not even conversant, I don't even know how to communicate with them. But Google Translator, it helps me a lot to communicate when I need it. So, but in future, the communication can become more easier, not only using the Google Translator, but having several applications which have been built on NLP so that we can have better communication. And to wind up this discussion or talk, I would like to wind up with this famous quote, which is one of the best quotes. I like it. It was stated by Albert Einstein, which says, computers are incredibly fast, accurate, and very stupid, actually. But humans are incredibly slow, inaccurate, and brilliant. But together, they are powerful beyond imagination. So this means whatever you feed in the machine is what you get. You feed it in with garbage, you get garbage. You feed it in with right data, you get the right information. So that marks the end of my talk today. You can follow me in my accounts and our website for AI4D website, Telesoft AI. And up to that end, I would like to say thank you. Obrigado, merci beaucoup. Arigatou gozaimashita. Back to you, Zephania.
So much, Gloriana, and a quite good presentation. I'd like also to welcome audience. If you have a question, maybe one or two questions. One or two questions. Maswali. Hakuna? Hakuna swali?
I have one.
Okay.
Hello, Goy.
Yes, yes.
Can you hear me?
Yes, I can hear you clearly.
Okay. Yeah, so I have a question. Like, you have told us you're doing research in NLP, and
yes,
you're focusing, like your research focuses more on the high resources languages. But can you share with us maybe if you have any thought on how that can contribute to building like tools for NLP for low resources languages? As we know, most of the tools, they are also available for high resources languages, but those tools are more into high level resource languages, but we use them too. For instance, we have some of the applications which are based in Swahili. For instance, maybe I can give an example. Maybe if it is maybe a chatbot. So how does those tools affect the performance of those what should I say? But my point is, how does the available NLP tools which are being created using high-level languages affect the applications which are being deployed using those tools. But the applications are of low resource languages. If you have any thoughts, maybe you can share on that.
Yeah, if I got your question clearly, so yes, thank you. So to respond to your question, I think we just go back to how, first of all, you know, at some point using high resource language tools and translate, to train the low resource languages could be difficult at some point, as we say that sometimes there is no word-to-word translation. Like you can translate a certain sentence maybe in, you can write a sentence in English and then translate it in Swahili. It may not have the same number of words or the same number of, the same number of words, or if you do otherwise, it can also have differences. But again, that is the challenge. So when you're training, it's not like you are going to get a very perfectly working model by using the high resource languages tools on the low resources, but at least it can improve on those similar languages. There are some of the similar languages which they have same lexical, same morphology, same, those are the kind of things you need to learn. You need to understand if they do have those similarities and take an advantage of using the one model that has been used to train a high resource language to use it with low resource language. So there are some of the issues that you need to look at. You cannot just say that I'm using this high resource language to train any low resource language if there are no similarities, there are no, maybe they cannot be used parallel, or you cannot accumulate. So one of the approach I would say, if you find there are so much differences, the best way you can do is to go with argumentation, their argumentation. But if you find they have those similarities in morphology, lexical, and syntax, and such kind of things, it can be beneficial for you to use the pre-trained models on high resource languages on top of the low resource languages. So if I responded correctly, let me know.
Okay. So
does that register to you?
Much for joining us, and we appreciate for sparing your time to make this happen. So thank you so much.
Thank you so much for the opportunity, and